Going with incense this morning. All right. Well, let me start off by saying, really nice job with service learning project presentations yesterday. Um, so I was really happy that everybody showed up. I only had two unexpected no-shows, which is fantastic. That's way better than we normally get with the in-person presentations. Um, and it was cool seeing the projects that I was able to get in and see. I know we had a number of visitors from outside the department come by, and they seemed to enjoy seeing what people were working on and listening to your talks about it and so on. And I just thought that was all really cool. So I'm interested in any feedback or comments or reflections from anybody on the presentations yesterday. So if we want to take a few minutes maybe and just kind of talk about whatever you feel like about that, I'd be really interested in hearing your comments.
I thought it was pretty cool
Yeah.
to see other people's what everybody else has been working on, the variety in our field as well as the engineering side of it. It was pretty informational and pretty cool.
Cool. That's great. And that's something that's usually even stronger when we do this in person, because for the past times we've done this, everybody's in one room, usually the digital lounge, and so you can just kind of look around the room and see what's sitting on people's tables, and some people will have hardware sitting there or a computer screen running a game they're building or something, and the in-person presentation is usually 2 hours, so there's usually time to like walk around and visit other people's tables, and it's always cool, I think, to see what other people are doing. I definitely like that too.
I also thought it was a good opportunity to get to present to other people. I know going into the workforce, it's super beneficial to be able to communicate your ideas and things that you're working on to other people, especially people who are outside of your typical,
Mm.
company that you work within. So I found it enjoyable to get the practice and present your projects to other people and have unbiased questions and just people who show interest. So
Yeah,
I
yeah.
really enjoyed it.
Really good points. Yeah, presenting is a really important skill. It's one that gets better the more you do it, and if you haven't done a lot of it, it's usually kind of intimidating, and it's not clear what to talk about. But yeah, what you said about people from outside the area is definitely key. If you talk to your classmates, or yourself about what you're working on, it's a bit of an echo chamber, right? It doesn't really force you to think about what am I doing, what is a computer game, what is a such and such, and so it can be enlightening to try to describe things to someone outside and to listen to an outsider's questions. So yeah, cool. What else? I had a friend a number of years ago, still a really good friend. He's been in IT forever, and he was at a party and he was talking to this woman who I think was in her 80s. And they got to talking, and it came out that he worked with computers, and she kind of shook her head, and she's like, "I don't understand computers." And my friend, he's super patient, and so he's asking her, well, you know, for example, what confuses you about computers? She's like, "Well, I have this computer, and when I want to stop it to shut it down, I have to hit the start button. And he had never thought of that because it's so second nature, you know, when you want to shut down your Windows machine, of course you hit the start button and then you select shutdown, you know. And it totally shocked him to, like, you know, realize he'd never seen things like that before. So outside perspectives can be interesting. Any other comments, feedback? Yeah, so logistics are interesting. Somebody said it would have been nice to see some of the projects in the other rooms. So, and again, in person, right, it's easy because you can just like look around the room and then you can walk across to someone's table. So this was the first time that we tried doing this online. We did a video version of it last spring. We don't do it in summer, and then in fall, as you know, we just didn't do SLPs. So this was the first version at an online, first attempt at an online version. Before spring's presentation, we're going to see if we can improve on this. And yeah, I think it would be nice to be able to see the posters in some kind of digest form, so that if you want to visit, you know, rooms to hear presentations or ask questions, you have more than just the name of the projects to go on. So I was thinking of like some kind of web-based front end where you can sort of like flip through pictures of the posters, or sound bites or something, and then use that to figure out which rooms you want to work in. Wish it had been a little longer. Yeah, so 15 minutes is a pretty short time, especially with, you know, logistics time at the beginning and end. And normally, you know, my intent was that people would stay for the class duration. Apparently some people showed up at 10 and thought they had to stay there till 12. And I think we mostly got that cleared up before they had spent 2 hours. Now Izad's students, their class with him is 2 hours on Mondays, and so they were staying for the whole 2-hour time period. But for us, we were just doing, you know, an hour during the regular class time. For spring, I don't know, maybe we'll schedule it outside of class time and it'll be a 2-hour chunk. We'll see. But yeah, it would be useful to have it be longer in some ways. And if you stayed 2 hours and you had the time, you know, to spend there, that's certainly not a problem. But, you know, potentially if you're in the 11 o'clock section, some people might have class at 10, you know, a different class and so on. So I was only expecting you to stay for the hour. So yeah, normally the SLP begins in fall, and that's where you do kind of the basic problem definition, initial exploration. And then in winter, you're kind of refining it to a first prototype, and then in spring, you refine it to some kind of, you know, sort of more advanced prototype. So with COVID, we didn't do anything in fall. And so this quarter, winter that we're finishing now, was basically, you know, the exploration of the problem space, coming up with an initial idea, doing the research and feasibility and so on. And hopefully at this point, you've got a better idea, you know, is this a project I want to continue pursuing? And if so, what's a reasonable timeline? What's a reasonable set of goals? You know, maybe you wanted to do X, and as you got into it, you found out that X takes, you know, A, B, C, D, E, F, G first. And so you're going to scale it back and say, well, I'm going to try to do A, B, C, and F, right? So, and then spring, hopefully you can work towards, you know, getting to some kind of you know, not a finished product, but, you know, some sort of something that feels like a good stepping stone, stopping or pausing point. Cool. Other comments, feedbacks, reflections? All right. Well, again, really nice job.
I did have one thing.
Yeah.
I agree with you about extending the time. I know in our group we only had, there were only two of us in that room, and we took up the whole 50 minutes between the two of us.
Oh, wow.
Between that and questions that people had for us.
Awesome.
So
That.
if we extend the time in the future, that'd be handy.
Yeah, that's cool. Um, and we could do it like, an option, like stay a minimum of an hour, but make it available for 2 hours, something like that. So I don't know. We'll look at the feedback we're getting on this and look at some option and figure out what we're gonna do in spring. But I definitely appreciate getting some feedback and some input from your side of things. And if you've got feedback that you don't want to share out here, right, you can send me email or come by office hours and we can talk about it too. And that's always fair. All right, cool. So this will continue in spring quarter if you're going on to 223, which if you're a CS student and you're planning to transfer next year, you should definitely be signed up for 223. And so this will continue, and typically you keep going forward with your idea and try to move to subsequent milestones. Yeah, I like the poster idea too, or download afterwards. That's a good idea. Um, and usually when we do this in person, people seem to either tape their posters to the front of their table or have them laying there, on the side. And so you can just kind of walk around and glance at, people's posters, and something catches your eye, and then you go over and you listen, and then if it sounds interesting, you start, asking questions and so on. And that's a model that will pop up. That's kind of a trade show model. Um, any of these industry trade shows where companies typically come out and release, or announce their new products for the year and so on. Same kind of setup. It's a bunch of booths, and this booth will have someone in a gorilla suit dancing to music because it gets people to come over, and then if somebody's in the area looking at the dancing gorilla, they might see something shiny on the table that catches their eye, and it's a marketing thing, right? It's trying to draw people in. So when this is done in person, groups will show up with bowls of candy or bowls of, little toys or other kinds of swag, or they'll wear, funny hats or something. I mean, there's all kinds of things that go on. If you go to a technical conference, a lot of times, people mostly do presentations of their research, but a lot of times there's also poster sessions. And poster sessions are basically like the SLP presentations. It's a room, and people have, typically a poster. It might be, multiple panels that's posted up on a wall or a display board. And people just kind of walk around and look at the posters, and if something seems interesting, then they can talk to whoever's there and ask them questions and so on. And it's sort of a less direct version of actually presenting a paper, because presentations, take a certain amount of time. You only have so many of those, but posters are another option. So you'll encounter this kind of format throughout your careers, most likely, and it's all good practice.
Hey, I have a question about midterm.
Sure.
So you were talking about a class that I think Scott is doing it. It's a machine learning
Mm-hmm.
class. Can you tell a little bit about that and how they're doing that on Zoom?
So Scott's class, it's CSE280, and it's a machine learning class, and it's this spring. I think it's 2 credits, but don't quote me on that. And I don't know what the exact prerequisites are, but I'm pretty sure everybody who's in this class has the prerequisites. And yeah, so somebody just said in chat, and I've heard this from other people, someone took it in spring, said it was insightful and interesting. Every student I've talked to who took it last year seemed to really enjoy it. And Scott, he's a really good teacher. He's very enthusiastic about the subject. And it's not part of the formal degree plan, but if you have time in your schedule, and if the cost of the 2 credits is not an issue, it's definitely a good option to consider taking that. And Scott could probably give you more detailed information about like the particular subjects and so on. Or, I think some people in here have taken it before, and so you could ask them in chat or in Discord.
I took it last spring, and I don't think you really specifically need anything, though it is helpful if you know a little bit of linear algebra.
Okay.
And a little bit about derivatives. It's helpful.
Mm-hmm.
It makes the math make a little more sense, but he doesn't go super duper in depth into anything. But,
Okay.
Between that and the textbook that he uses, it's pretty handy, and then he uses Jupyter Notebook.
Oh, cool.
To essentially kind of make it such that you have text and equations and code all on the same pages. So it's pretty fun.
That sounds fun. I should take that actually. And hopefully anybody who's planning to transfer in fall has either taken or will be taking linear algebra in spring. So that should be all set. On the subject of transfer, anyone who's planning to transfer in fall hopefully has already applied to their target university. Most people are looking at WSU, so hopefully you've already applied. If not, do that right away because you want to get certified for junior standing and so on. How hard is linear algebra? Well, I can't answer that meaningfully, but I suspect some other people in the class can. But linear algebra is a different kind of math course. It's very different from calculus, I would say. When I took it, it was a lot about proofs. It was a lot about sort of theoretical concepts. But linear algebra is kind of 3 different topics. And sometimes you get a mix of them. Sometimes you just get one or another. But it's a combination of matrices, equation solving, and looking at typically higher dimensional spaces geometrically. And those are all the same thing. If you're doing nothing but matrices in linear algebra, you're also doing equation solving, and you're also dealing with hyperplanes inside higher dimensional spaces and so on. But depending on the treatment of the subject, it can look like just one of those things or just 2 of those things. But I don't have a way to answer how hard it is. I guess it depends compared to what. There you go. Fun and easier than calculus, says someone. So that's cool. Let's see. So transfer. So we work very closely with WSUV as far as what courses at Clark correspond to which courses at WSUV. We also work with UW, but it's not quite the same situation because UW has very few requirements for their CS program. You can come in with without 223, for example. Well, you can't take 223 for credit at UW. They don't accept our 223. But I don't think you need the physics courses and so on and so forth. But UW or WSUV has very specific requirements to be a 3rd-year student, to be able to take 3rd-year classes when you get there that first fall. And that includes, the whole CS sequence and engineering 270 and 250 and so on. WSUV does not require you to take physics to start as a 3rd-year student, but you need the whole physics sequence to graduate with a bachelor's from WSUV in computer science. And so typically you want to take that before you transfer. Otherwise, it's another set of credits to be taking while you're taking a full load. And that's the same thing with, History 128, Women's Studies 101, Econ. Those are courses you need to graduate from WSUV, so you take them before you transfer. Yeah. And at WSUV, once you apply, right, talk to somebody in the CS program. It's a little different. I mean, you can apply to, get a bachelor's in computer science at WSUV, and I don't think you have an issue where you don't know what your program's going to be. I mean, you can go in and you can say I'm doing computer science, and you start taking the courses for that, and at the end of your coursework, if you've passed everything, you get your bachelor's in CS. It's a very straightforward process. Yeah, they require econ, but you can take it in the summer, because the usual schedule of courses at WSU doesn't include summers. It's 2 semesters, fall and spring. And so summers are an opportunity to take, econ or pick up other courses that you were missing and so on. You just have to do it before you graduate. Yeah, it sounds like a fun summer class. Cool. And yeah, I think they want Econ 201 or 202, macro or micro. And Physics 243 in the summer, yeah. Yeah, and physics, if you're in a situation where you're not able to complete the physics sequence before you transfer, there are options there, right? You can take it after you transfer. There's also an option to take the physics courses during the summer at PSU. You can actually take all 3 physics courses in one summer at PSU. And so we kind of informally call it Summer of Physics, but it is a intense way to spend your summer, because that's all you do the whole summer is physics. But it gets it done in one fell swoop. Sometimes immersion can be good. It's like if that's the only thing you're doing, if you wake up and you do physics and you eat lunch and you do physics and you go to sleep and you dream about physics, sometimes that's a really useful way to study something. Provided you have the flexibility to do that. All right, cool. So if you have other questions or such about transferring, right, definitely let me know. Most likely, if you're in this course and you're doing 223 in spring, you're intending to finish your Clark work this year, which probably means you should be thinking about transferring in fall, which means you should have already applied. So if you have any questions about that or concerns, definitely let me know. Send me a note or come by office hours, and we can go over your plan. Do you have any issues downloading anyone's repos for PA5? Well, I always have issues. I think I got 37 repos out of 45. And yeah, GitLab was down last night for a few hours, which is pretty unusual, but it does happen. I was able to get to their website, but trying to push things out, it was timing out, and then they seemed to fix it, and it started working again. So So that was good. All right, so yeah, let's talk about PA5. Is there a logging feature to see if our repo was downloaded? No, there's not, but I did download your repo. Actually, 2 of them. Yeah, you're welcome. So PA5, I will start grading this today, and it usually takes me a few days, so these may not be ready by tomorrow. Plus, normally I have the weekend to grade, so it'll be a little while, but I will get them graded more or less as soon as possible and get some feedback to you, and then we can talk about general feedback and such. But any urgent questions up front about knapsack problems, dynamic programming, or PA5? So the biggest issues that I was hearing about from students yesterday was mostly related to trying to do the count of the number of items. And there's really 3 separate things going on in PA5. First is, here's my knapsack with this capacity. Here's a list of items I can choose from. What's the most value I can get by putting those into my bag? And that's your integer max val function. And then there's the second problem of, okay, I know that I can get this much value out of the bag. How do I do that? How many of each item should I put into my bag? And so that's the second problem, and that's one that a lot of people seem to be having issues with. And then there's the dynamic programming, which is, either that first one or that second program works great, but it gets really slow when my bag has a capacity of 100, right? And that's the caching, and that's another set of issues that people had trouble with. And one of the tricks to debugging is being good at making bugs appear, right? So if your bugs only pop up once in a while, it's really hard to debug. If you can make your bug appear every time that you run your code, you're going to be more successful at figuring out what that bug is all about. And you've heard me say, try to find a small test case. So if your code is seg faulting, with an inventory list of 20 items and a capacity of 50, it's going to be a really long debug session to go through, that much capacity and that ridiculous number of recursive calls, possibly until you get to your seg fault. So an early step is try to pare down your problem. Try to, make a smaller inventory of items. Try a capacity of like 2 or 3 and see if you can reproduce the error. And that's going to make it easier to debug. And that's part of kind of the art of debugging is finding good sample problems to work on. And being good at, coming up with a set of input that makes the problem appear and either putting that in a file and redirecting from it or copying and pasting or, these kinds of skills working with command line tools, these help you in debugging. Yeah, and rubber duck debugging. So get a rubber ducky and explain your problem to it, right? This is a technique a lot of people use. And the process of verbalizing what your problem is will let you sometimes hear it for the first time, right? I'm making these little Z80 boards that I was waiting for shipment from China on and so on, and I've got a blog where I'm writing about them, and I was posting an update, and so I was typing in hey, just, ordered my next batch of boards, and it's got this feature, and it's got this feature, and it's got this other feature. And as I was typing this other feature, and I started explaining how it works, I was like, oh, and I suddenly realized I had a bug in it. And, I had made this circuit design myself. I had written down what I was going to do. I wrote a circuit for it. I laid it out in the printed circuit board, did all this stuff, right? But until I started, basically describing it to somebody else, in this case typing it into my blog, I didn't actually hear what I was saying. And once I heard it, I realized, oh, that was wrong. In this case, I was putting an OR gate on the wrong signals, right? And it was totally obvious to me once I had that experience of trying to explain it to someone. So yeah, rubber ducky or messaging friends on Discord. Or things like that can help. I had a weird bug that caused my program to get the right answer sometimes, but not others. So yeah, initialization, that's another one. And that's one that Valgrind can help you with. Even though we don't expect memory leaks in here, Valgrind will do a pretty good job of telling you when you've got uninitialized stuff. And if you want to make sure everything in an array is 0, make yourself a for loop and initialize it. Don't ever worry, at least for my classes, don't ever worry about doing extra stuff. Maybe this is already initialized, but, I want to make sure, so I'm going to set it equal to 0. And I want to set every element to 0. Maybe I can do that with curly brackets in the declaration, but I'm just going to write a for loop. I'm going to set every element to 0. Don't be afraid to do that. So yeah, there's issues with not initializing. I saw some issues with loop indexes. So if you make an array of 128 items and you want to initialize every item, you want to go from 0 to 127. So, I less than or equal to 127 or I less than 128. And if you do less than or equal to 128, you're initializing something outside your array. And there's no telling what's going to happen there. If you do less than 127, you're not initializing the last element. So things like that. And I'm not going to run Valgrind against your code. I'm not expecting memory leaks because I'm not expecting dynamic allocation. So I'm not going to be testing with Valgrind. But it can help you if you've got things that are setting up little time bombs. Not expecting dynamic allocation. You did dynamic allocation, didn't you? So I offered some simplifying assumptions, right? So that you wouldn't have to do mallocs, but there's nothing wrong with doing mallocs. At times it looked like my knapsack program was frozen. Then I learned it was just taking a long time to do maxval. Yeah, so okay, I'll take your word for it. Yeah, so if the program's taking a really long time, it's something in the dynamic programming. And that can be tricky to find, but your general setup is and this is for most kinds of dynamic programming. So dynamic programming is really about adding a cache to your code, right? So here's my maxval. And I don't know, struct whatever, maxval, capacity, other stuff, whatever. And what are you doing here? I don't know. Do stuff. Loops, ifs, recursion, magic. You got curly brackets somewhere and all kinds of stuff, right? And at the very end, you say return, best answer or whatever. And there's your curly bracket. All right. So let's say this is what your code looks like. And I don't know what all of this stuff is. This is all the stuff that, some people spent, till like 5 in the morning getting to work, right? This is with no dynamic programming. This is just, your max val function takes a bunch of arguments, including a capacity of your bag, and returns some kind of answer. Maybe it's an int if you're just finding the maximum value. Maybe it's a structure of some type if you're returning item counts and so on. Okay. If you want to add dynamic programming to this, you do two things. In the beginning, so you have some kind of cache, right? And it's got to be a cache of whatever type of thing your max val is returning. So you have some sort of struct, whatever, cache. I called it save in our Fibonacci example, but you can call it whatever you want. And now you do two extra things in your function. You don't change anything in here. Nothing in here is affected by adding dynamic programming. You add one statement in the very beginning, which says if cache cap dot, typically it's your max value, is bigger than 0, return cache cap right? So this is looking to see if you've already calculated this maximum value for this capacity. And if you have, you've saved the maximum value and it should be a positive number. And so if this value is positive, just return the value, and you never do any of this stuff because you return right here. If that's not the case, and the first time you try to find max val of some capacity, this will not be the case. You'll do all of your stuff, which presumably is already working perfectly. And now you do one extra thing before you return, save your answer. Cache bracket cap equals whatever you're about to return, best answer in this case. So the first time you try to find max val of 30, you're going to check to see if the max val in that cache array is positive. It's not. You're going to do all your work to find max val 30. But at the end, what do? Before you return the answer, you save that answer at cache bracket 30. And now, in the future, if you try to find max val 30, what's the first thing you do? Check cache 30. You're going to find an answer there. You're just going to return it. Okay, that's what speeds it up because you're not doing all of this stuff the next time. And the only thing missing from here is you need to initialize this. And in this case, we're initializing it by setting all the max vals to 0 to indicate that there's no value stored in here. Now you could put a flag in there if you want and set that to 0 to say is this valid or not. And this can be a global variable. If you're putting all your code in one file, just put this in the very beginning of your file outside of main, right? And then it's global everywhere. Or you can pass this as an argument to your max val function, and then you don't have to deal with a global, because if you put this code in a separate file from main, main can't initialize this unless you start setting up extern keywords and things like that. So you could put an initialized function in this file also, but it's probably easiest just pass this to max val as another argument, right? But the punchline here is, right, here's all the stuff that you already got working to add dynamic programming. One statement in the beginning, one statement at the end. If you start messing with your cache inside here, you're probably not doing dynamic programming the right way. Right? There may be ways you can mess with your cache inside here, but don't. Right? If you want to make this work and you want a minimum amount of effort, just check it in the very beginning, set it at the very end. All right, and generally when people were having issues segfaulting or things not speeding up, it looked like they were monkeying with the cache inside this code that already worked. So go back and look at that, and as always, right, feel free to come by office. We can look at code and work on details. When a program ends, does all memory get cleared, or is it truly orphaned and at some point it diminishes the available memory? In Unix, when your program exits, all the allocated memory gets freed. So you don't actually get memory leaks. Yeah, I'm pretty sure that standard Unix actually does free it. But not all systems do. But I don't know, could be wrong. Last I checked, that was the case. Yeah, that is kind of magic, right? I mean, because it really is 2 lines of code. But yeah, it just like viciously prunes the recursion tree and speeds things up pretty significantly in a lot of cases. All right. Any other comments? I've never used anything other than malloc, so alloc and cialloc and those different versions of malloc, and I think they're freed the same, but I don't know. But if you look at the man page for those, it should tell you how to free the memory. And as far as I know, it's usually just the same free function, but that's just as far as I know. So if you haven't noticed this already, I tend to have a habit when I'm programming of figuring out how to do something and sticking with it. And it's partially laziness. Well, it's primarily laziness. And if I have a good reason to do something different, I will. And I still learn new things occasionally, but by and large, a lot of what I do in C, a lot of what I do in Unix, is the same stuff I was doing 40 years ago when I first learned this, right? And it's kind of cool that the language has been stable enough, and Unix has been stable enough that the stuff I was doing 40 years ago still works. The way I use VI today is mostly the way I used VI 40 years ago. I've learned a few new things that I like to use, but probably 95% of what I do in VI, same exact set of commands that I first learned 4 decades ago. And there aren't a lot of editors that even survive for 40 years, let alone allow you to do exactly the same things and get the same behavior out. I mean, Word, for example, changes, it seems, every few years, and where you used to do this to open a new file, now you have to do something different, And there's something to be said for the value of habits, right? This is arguably one reason why humans have been such a successful species in terms of, longevity, because we're really good at forming habits. And so a coding environment, a development environment that supports and encourages habits, can be a good one to work in. So just something to keep in mind. All right, let's talk about trees. So we want to talk about AVL trees. AVL trees are a form of balanced tree. So we know what balance is, right? And you've coded up, a balance function, AVL. So it's 3 initials, which I would pronounce poorly. But these are the people who came up with this. So the idea is having a balanced binary search tree. And the reason we like a balanced tree is because, let's say we've got a tree with 15 pieces of data in it, right? And it's nice and full. Everything up here is filled in. When my tree looks like this, right, theoretically, I can store twice as much information in a different tree that's only one level deeper. I just add one more set of nodes on the bottom, and this tree has 31 pieces of data in it. Twice as many as my previous one, but all I've done is add one more level. So the height of the tree has increased by 1. And with most of our algorithms for trees, search, traverse, insert, delete, right, we typically begin at the root and we travel down and we follow, branches to the left or the right. And the time it takes to do an algorithm is basically how many times you have to hop down until you get to your action point. And that's basically the height of the tree. So the time for an algorithm is on par with the height of the tree. So somebody posted the names. Thank you. AVL is the initials of the people who came up with this. And I think this was done in the 50s, maybe the 60s. It's an old algorithm. So the time to do your operations on a BST is basically on par with the height of the tree. So the idea of a balanced tree is, in some sense, trying to come up with trees that aren't too tall unless they need to be. Now, if I'm going to have 1,000 nodes in my tree, it's going to have to be about 10 nodes tall. Because, a node only has 2 children. You've got to grow your tree as you put more and more stuff in it. But, 31 nodes I can store in a tree with just a few levels, but I could also store it in a tree that looks like this, where it's just a big, long, skinny branch. And here, the time it might take to add something new to our tree, well, I would have to start at the root and work my way all the way down to a leaf node, right? And it's going to take, something like order n operations. But if the tree is balanced, this is where we get this nice log n. Because log n is basically the height of the tree. So we're interested in balanced trees because it maintains this high efficiency of doing tree operations. So AVL trees are one particular type of binary search tree that will be balanced. And the key to having a balanced tree is to keep it balanced. We don't really take our tree and then at some point do a balance operation on it. What we try to do is keep it always balanced. So if our tree starts off empty, it's null. A null tree is balanced. That's a base case. And what do? We insert and we delete. So all we have to do is anytime that we add a node or delete a node, make sure our tree is still balanced. And if it's not, we change its shape to restore it to a balanced tree. But this can be tricky. So this is still balanced. If you work through it, you'll see that, the height of this tree and this tree differ by 1. This is a balanced tree. This is a balanced tree. But let's say I want to add the number 1. By our straight algorithm that we used for PA4, we would start here, we'd move left, we'd move left. We can't move left anymore, our 1 would come here. This is unbalanced, right? This tree has a height of 2. This tree has a height of 0. So the heights differ by too much. So this 1 is making things unbalanced. Well, we can't just move this 1 over here or here, because it's still got to be in a certain order. It still has to have this property of being a binary search tree. So what we're going to do in this case is we're going to take this and we're going to change it into an equivalent tree that's more balanced. And this is basically the same thing as this. It's a binary search tree. 1 is smaller than 5, 10 is bigger. But this is nicely balanced, whereas this is lopsided. And so if we take this and we use it to replace that lopsided piece, there's the same information in a binary search tree, but this tree is balanced. So the AVL algorithm is really about how do we deal with inserting or deleting a node from a balanced tree. What do we do to change the shape, to rebalance it and keep it in the proper order? All right, and it's a algorithm. So we'll talk about that tomorrow, and we'll go through some specific examples, and then we'll look at some code related to that. All right, cool. Have a good afternoon. I will see you tomorrow.